Hello everyone. In this video, we're going to be taking a look at an interesting infinite radical. So we have the cube root of 1 plus the cube root of 1 plus the cube root of 1 plus, okay, you need to stop. Just goes on forever, right? Dot, dot, dot. Now, we're going to evaluate this radical expression, and this is not an ordinary number. This is actually a very special number. But I just want to remind you something that we've done recently. I believe I've done a short on this. If you have the square root of 1 plus the square root of 1 plus the square root of 1 dot dot dot, this becomes an interesting number, and that is called the golden ratio, right? Okay. Now, golden ratio is very special. You can find it in nature, so on and so forth. But this is also very special. Why? Because it is called the plastic constant or the plastic ratio. What is that supposed to mean? Well, here's a little bit of information about the plastic ratio. It is known as the plastic ratio. I believe that that letter is rho. The minimal, I don't know how to pronounce it. Is that Pisset or Pisset number? The Platin number, Siegel's number, so on and so forth. So it's a very interesting constant, and this is the value. So you already got the answer, but that's not the end of this. So let's go ahead and take a look at how we can find this plastic ratio. By the way, Number File also made a video on the plastic ratio. You can go ahead and take a look at that video as well, because it gives you a lot of details about this special number. All right, so let's go ahead and take a look at our expression one more time. We have the cube root of 1 plus the cube root of 1 plus the cube root of 1 dot dot dot. Goes on forever. Now, what is that equal to? We kind of saw the value approximately, right? It is an important constant, and I'll give you some links. Hopefully I don't forget. I'll share them down below. So in order to evaluate this constant, we're going to do the same trick that we used before. We're going to set it equal to x. You can also set it equal to p for plastic ratio, so on. How about using a p here? Let's do it. Okay, great. Let's go ahead and set it equal to p. Now notice that this part is the same thing as the original. So this is an expression that contains itself infinitely many times. That's what happens. So this is also p. So we get cube root of 1 plus p equals p. Great. So what are we going to do with this? We're going to cube both sides because we want to get rid of the cube root. And obviously there's something nice about cubing both sides. We're not going to introduce extraneous solutions. So we're going to get the following: 1 plus p equals p cubed. And then if you put everything on the same side, you're going to get p cubed minus p minus 1 equals 0. Awesome. This is a cubic equation, and it's going to give us the plastic ratio. Yay. Let's go ahead and find out what it looks like. Okay, how do you solve this equation? We're going to be using the infamous cubic formula. How do you use that cubic formula? Let's go ahead and take a look. Okay, great. So here's what we're going to do. First of all, we're going to write this interesting identity. If you take a plus b quantity cubed, and from that subtract 3ab times a plus b, you subtract the two terms in the middle. Remember the binomial theorem. And then you're going to end up with the sum of the two cubes at the ends, right? That's what happens. Fairly simple identity, but this helps us build the cubic formula. So I'm going to call this p and call that p. And everything else falls into place. ab and a cubed plus b cubed are going to be constants. So once I find, I'll come up with a system in a and b, solve that system, find the values of a and b, and then add them up, and that's going to give me the value of p, which is the plastic ratio. Awesome. Let's go ahead and do that right now. So how do I compare this expression to mine? Notice that the coefficient of p here is negative 3ab, and the coefficient of p here is negative 1. So that means negative 3ab equals negative 1, which implies ab equals 1/3. Great. Let's go ahead and save that for future use. And the second part, the constant on the right-hand side, is supposed to be a cubed plus b cubed. And here, if we add 1 to both sides, let's do a little quick trick. We're going to get a cubed plus b cubed equals 1. So we kind of get a system from here. Not quite there yet, but let's go ahead and cube both sides. We're going to get a cubed b cubed equals 1/27. Awesome. Now here's what we're going to do. We're going to use substitution, replace b cubed with 1 minus a cubed, plug it in here, and you'll end up with a quadratic formula. A cubed times 1 minus a cubed equals 1 over 27. And if you distribute a cubed minus a to the 6 equals 1 over 27. If you put everything on the right hand side, a to the 6 minus a to the third plus 1 over 27 equals 0. Awesome. But we do need to do a little bit of substitution here, so bear with me. Let's go ahead and call a cubed. Let's set it equal to c because we used b. Okay, a, b, c. So now we get the following. B, not b, to be or not to be. So that's going to be c squared minus c plus 1 over 27 equals 0. Awesome. Yay, from a cubic equation, we ended up with a quadratic. That's how you solve a cubic. That's actually one of the methods. And if you're trying to solve a quartic, then you end up with a cubic, which you can solve by turning it into a quadratic, like this one. Okay, but quintic, no, you can't do it. Unfortunately, very sad, right? Anyways, so let's go ahead and solve this equation. Easy. C equals negative b plus minus the square root of b squared minus 4ac. I don't know if it would make sense to multiply. Probably it would. Let's multiply both sides by 27 to get rid of the fraction. It's going to be much nicer. So now c is going to be negative b plus minus the square root of b squared minus 4ac. The reason why I wrote it that way is because it's going to simplify. B squared minus 4 times 27. We can definitely factor out a 27, and this is going to be 2 times 27, which is 54. Let's go and find the value of c from here. So inside the parentheses, you're going to, under the radical, 27 times 27 minus 4. That is at 23. Great. 27 can be written as 9 times 3 times 23. So we can take the 9 out as a 3, and inside we're going to have 69. Awesome. We got the values, and everything is divisible by 3, which is awesome. Plus minus the square root of 69 over 18. Beautiful. This is the value of c, but remember, a cubed is c, so a is going to be the cube root, but there are 2 cube roots because the other one is going to be b. So a can be written as cube root of this, and b can be written as the cube root of the conjugate. And guess what? P is going to be a plus b, which is the cube root of 9 plus the square root of 19 over 18 plus the cube root of 9 minus the square root of 69 over 18. And guess what? That's going to give us the plastic ratio. Let's go ahead and take a look at the graph real quick here, and you're going to notice that we get the exact same solution on the graph. And this cubic equation, which gives us the plastic ratio, only has one real solution. The other solutions are complex. How do you find them? Polynomial division, or otherwise use a calculator, because they're going to be quite complicated. But anyways, this is the plastic ratio, and this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.